Calculus! This is AP Calculus Lesson H-4, Specific Absolute Extrema. Today's date, of course, is Friday, January 25th, 1/25. We have our date, we have our name on the paper. Let's go ahead and do this problem, or do these notes. All right, so finding minimum and maximum. This is almost the same thing that you did in Unit 7 when you are doing particle farthest to the left or the right. So that's exactly what I'm going to say here for the notes. This is very similar to finding the particle farthest left and right. What was the tool or the method in which we found farthest to the left and the right? Do you remember the general procedure?
So you would just check all the suspect points, like where velocity equals 0?
Yep, CVs.
Oh.
So after you find CVs, those are going to be the times that you're going to have to check, or the X values that you're going to have to check. And then what do you do with those?
And then you make a table, and you start plus change with the integral from start to wherever the CV is.
Yep. And then you just see which one is biggest or smallest. Exactly. It's going to be the same thing for us. It's just.
That was last one? That was the last unit?
That was last unit, yeah.
Sounds like it was this unit.
Yeah, this unit goes by fast, right? Yeah, so, and by the way, here we are in our unit guide. We're on 8-4 on Friday, so we're doing self-checks all next week into a fix-up on Friday, which means test is that next upcoming Monday. All right, so coming in here, who wants to read? Go for it, Rochelle.
On a chilly Saturday morning, a water tower in Davis starts with 1,200 gallons of water. Water enters the tank at a rate of W, where Wt equals 95 square root of T sine 2 of T over 6. Water leaves the tank at a rate of R, where R of T equals 275 sine 2 of T over 3. Both W and R are measured in gallons per hour.
All right, yeah, thank you. And that was beautifully read. The one thing I can improve it's by saying sine squared of instead of sine 2 of. But that was perfect.
Oh, there was something on the homework too with sine squared. How did you put that on the calculator?
So on the calculator, you do sine of the thing. So in this case, sine of, it would be x over 6, and then all of this thing squared. That is the equivalent of sine squared of t over 6. Yeah, the way that we write it with trigonometric functions is by putting that squared there in case you forget to do it at the very end. I think that's the reason. It never really made sense to me. That's my logic. So there's probably a reason I should look up, but I don't know it. We have our units. Let's go ahead and look at that interval on our calculators, which means I hand out the go ahead and graph this on your graphing calculators. Get in your review. That means I'm opening up my emulator file, open recent TI-83 plus. All right. So, someone just shout out what they're doing, and I'll do the same thing that you're doing. You can just tell me the general procedure. Anyone?
Can't talk while I'm doing it.
So the first one would be 95. Second.
Oh, so you're just plugging these in. So you can just say, I'm putting in the functions for y1 and y2.
Yeah.
All right, I'll do that with you. So 95, and then I do second square root. What do you mean one at a time? Like 1 in y1 and 1 in y2?
No, like 1 in y1, and then you do everything, and then you put the other one in y1.
No, you should definitely put them both in right now, and I'll tell you why in a sec. But yeah, that's a good question. Definitely put them both in right now. So 95 times square root of x is going to be times sine of t over 6, so x divided by 6, and that thing squared. All right, and then y2 is going to be 275 times sine of x divided by 3, all of that thing, x divided by 3, all of that thing squared. Cool. And our window is going to be between 0 and 18. 0, enter 18. And before I graph, and maybe you already have, I guess I can just graph it with you. There is something that I told us, I think it was last unit, where I said, if you ever have two functions, one positive, one negative, do this one thing to make it equal to just one graph. One graph is easier to see. you remember what to
Oh,
do?
you like make y3 subtracting them, or add?
Yeah, make y3, subtract them. So because both of these are technically positive functions, so we have this first function that was graphed was wt, so this is wt, and you can see it down here. Wt is that first blue arc, or the non-dashed line, and r of t is that one that goes up and down a few times. Instead, if you want to graph them subtracting each other, then we'll be able to find values.
We all got different things.
We did?
Yes, we did.
All right, so if you got different things, go back to your y equals and see if you got the same thing as Mr. Sindel.
And also make sure your calculator is in radians.
Radians.
Yes, and that will mess up Rochelle more than you guys because she's in pre-calc where we use degrees.
And yours is in radians.
I'm in radians.
I
Okay.
know. Okay, so I'm gonna get close because
Yeah, I know. I can see either still.
You can turn off the lights and it's
Yeah,
easier
I know,
to
but
see
we
too.
still can't see.
Okay. I wish there's a way to make this big. There probably is.
Please, we usually don't have to be able to see, but
View.
I have some extra parentheses. So.
Oh, you forgot. Wait.
What? Wait.
Oh, never mind.
Oh,
What?
I see what I
I
did
like
wrong.
it's-
I'm pretty sure mine is correct because it matches this graph down here.
Yours
Yeah,
is
mine
correct.
is
I
too.
just. I see why I didn't click on it.
What was the error?
I forgot the.
Forgot the square and parentheses. All right. Yep, those are easy mistakes to make. It's good to get those mistakes out of the way right now. That way you don't make them later.
like 10 million extra parentheses.
Yeah, you don't have to have too many parentheses as long as you remember what your order of operations are. Just squish them all together.
Okay, so I got it right, but my view isn't very well. I don't know why.
Hit zoom 0 again. Hold on. Give it a sec. Get still thinking. There it is.
Okay.
How's it going, Arrow?
I think this is more promising than what it is.
Hey, yeah, that's perfect.
Okay, good. Yeah.
All right, everyone has the exact same graph. We're all on the same page. All right, so that is this first graph. So you can actually do it both ways. I'm going to teach you both ways. And you're going to decide whatever is easiest for you to remember, what makes most sense for you, because I really emphasize doing math in all the different ways as possible, as much time as I have to teach. So if you want to do it this way, we need to find these intersection points, because this interval right here, is it increasing or decreasing for the amount of water?
Decrease.
Increasing or decreasing?
Wait,
I don't know. I'm
I
done.
think it's decreasing.
So remember, W of t is water coming into the tank. R of t is water leaving the tank.
Also, wouldn't it be leaving?
It would be decreasing because yeah.
This is decreasing. So I'm going to do a negative here. Do it in your notes as well.
So if you shade that area between the two, wouldn't that be like the integral of the total change?
That would be the
Not
integral of the
integral
total change.
It'd be just the total change.
Total change, but it wouldn't be a negative total change. Exactly.
Yeah, it would be the total change, but not the total, but not the actual level change in the level.
Right. It just measures how much it's gone up or down, but it doesn't tell you which direction it went. All right, what about this one? Is this going to be positive or negative change?
Positive.
It is positive. And then finally, this final little area over here, I guess there's technically like a little bar right there because we cut it off at 18 for the domain, is going to be negative because the red dashed function, which is our negative function, is on top. Precisely. So in order to find out when the maximum amount of water is, we have to separate it into these three parts and calculate each of these individually, which means first, to even find this integral, we have to get the bounds correct. So to find the bound, I have to find the x-coordinate of this point A. I have to find what this number is. You can do that with this graph. So coming back to your calculator, do second trace, so you go to calculate. So you're calculating, and guess which one it's going to be. It's logic. You guys can get this. Of these values, 5. Yeah, it's the intersection. So you do 5, and then you just hit enter, enter. And your guess, oh yeah, because there are multiple intersections, so that's why the guess is important. I'm going to guess right there. Boom. And it tells me 6.495. So write down on your notes too, 6.495. Did everyone get that? The reason why you can just hit enter, enter instead of having to go up and down to select the functions is because we only had 2 functions. So as soon as we select the first one, it's automatically going to select the second function. If you had 3 functions, then you'd actually have to be careful about which intersections you're finding. All right, now go ahead and find your other intersection over here for point B. So it's going to be second, trace. I go to intersect, so 5. Enter, enter, and I'm going to guess out here, and I can see on my graph down here it's about 13, so I'm just going to enter 13 instead of scrolling over, and I hit enter, and it says I got 12.975, rounding, 12.975 after I rounded to 3 decimal places. Sounds good?
Yeah.
All right, cool. So let's go ahead and do it the second way, which so John Wynn, of course, who I haven't talked about for a while, he always suggests that students always do it this second way.
Yeah, I feel like that.
It is
More logical.
It's more logical and it's easier too. It just requires one additional step on the calculator, which is the easy step, but from there on out, you don't have to think about which one is negative, which one is positive, which function belongs to which y1. So on y3, we're going to say y1 minus y2 because y1 is our positive function, y2 is our decreasing function. So y3 is equal to y1 minus y2. Do you remember how to do that?
And then it vars, y-vars function, enter, and
Yep, exactly. Yep, var is right, enter, enter, var is right, enter 2. So y1, so I want to insert a subtraction sign, y1 minus y2. And I'm going to not graph y1 and y2, so I come back up here and I hover over the equal sign and hit equal, or enter and enter over the equal sign, and this arrow is the reason, the answer to your question. This is why you want to graph both y1 and y2 at the beginning, because you can immediately then do y1 minus y2. And then you don't have to even worry about this hard to interpret graph, and I'm going to go to zoom 0 again to graph this function. This function is way easier because we know that this is decreasing because it's below the x-axis. This is increasing because it's above the x-axis. This is decreasing because it's below the x-axis. So this is going to graph on the side. While it's doing that, let's go ahead and label this thing. We know that this is the negative area. This is also negative area. This is our positive area. These x-coordinates should be the same. Let's just check one of them, and we can assume the other one is the same as well. How am I going to find the x-coordinate to do my bounds for my integral if this was my graph?
Calc
Second.
0.
Second calc, yep, and then I do the 0, so I hit 2. My left boundary, and I'm going to guess here, my left boundary is just going to be 0. My right boundaries, I'm just going to put 10. Any number in between there, 9 is a horrible guess, but it'll work. And it gives me my 0 as 6.495, 6.495. It matches! Woohoo! 6.495. 6.495. I'm not going to do that process again, 6.495. I'm just going to rewrite 12.975. 12.975. That's a point right there.
who knows where this is.
Oh, maybe we should check it. You can if you want. All right, so from there, I'm going to use this graph for whenever I'm doing pretest or test solutions and the self-check, because I agree with John. It is easier. Let's go ahead and use our table method. Again, we're trying to answer this question that we forgot about up here. When does the maximum amount of water occur? Well, let's take a guess. Let's take a guess right now. Looking at this graph, do you think the maximum can occur at point C?
No.
No, it is impossible because we have this giant negative area. The AP graders know this. They do not expect you to test 6.495.
So just leave that out of your table.
Yeah, you can be logical about it. If you want, you can include every single CV, but if you're smart, you can eliminate a few. In this case, you can eliminate this one because we have the giant negative area when we're looking for a maximum.
So it's either t equals 0 or t equals 12.975.
Yep. You don't even need to check the endpoint because the endpoint ends with or by following a negative area. So you really need to check, as Ben said, the start and D. You don't need to check the end. I know I always said start, all CVs, and end, but now we're being logical about it. We're only going to check start and point D, being logical about that.
This is going to be so hard on the AP test.
Again, if you are ever confused about the logic of this, always check all CVs, always check all start and end points, and you will get it correct. But you can save time by trying to be smart about it. So my T, I'm going to check 0 and 12.975. What is the middle part of this table going to be?
Start plus change.
Yep, start plus change. What is my start?
1,200.
Oh yeah, there it is. It starts with 1,200 gallons of water, so all of my starts are going to be 1,200, 1,200. Ooh, got some lag there. That's going to be adding to the integral from 0 to 0, so I don't really need an integral there. And this is going to be the integral between 0 and 12.975. What do I write in here for 12.975 for the integral? What should I write?
Would it be W of t minus R of t?
That is correct. W of t minus R of t, all that in parentheses, dt. Again, if you just did W of t minus R of t, I don't think they'll take away points, but this is being pedantic and formal, and I love it when you are pedantic and formal with me.
Also, Desmos won't accept it if it's not in parentheses.
Oh, really?
Yeah.
Oh, cool.
So you have to have WT minus RT in parentheses.
Good job, Desmos, teaching us to be correct in our mathematics. All right, so from there, I need to calculate both of those. Well, I'll do the easy one for you. 1,200 plus 0 is 1,200. You're welcome. You guys have to calculate this thing now. And again, you can do it with the graph or you can do it with the non-graph. Graphing takes a little bit longer, but we do already have it up. I'm going to do, I guess I'll do it graphically really quick. Second trace 7, 0, enter. 12.975, enter. And I get...
It's kind of worth it because it's satisfying to see it filling in.
Okay, no, that's true.
Did you put for your lower limit at 0?
I did, yes.
Why?
Because you start at 0.
Yeah, you always are going to start at whatever the start time value is. And that's, I guess I should be revealing this now, but I should be doing this because I'm teaching you. On the AP test, there oftentimes you do not start at 0. They'll say, time just happens to start at 3. And then you'll have to remember this bound starts at 3 instead of 0. You've been warned, so now you won't be as surprised.
Oh, I'm going to be so stupid and just put 0.
This is 497.441. 441. And again, because I just calculated the integral on my calculator, if I go second quit and I just do answer plus, or just hit the plus button, plus 1,200, it'll do that for me since we have a calculator, and it'll tell me that's a weird thing, that this is 1,697, although we probably could have done that by our heads. 1,697, come on now, 90, oh my god, 97.441. Therefore, our answer, when is the water tank at its maximum?
At 12.99. At t equals 12.975.
Yep. Highest at t is equal to 12.975. What are we missing? Can't spell highest, apparently.
And you also need the amount.
You also need the amount. You should always be doing this just to be careful. What is the amount? I took off some points on the last pretest and test because some people didn't do that. Just put both the amount and the time. Time is 12.975, and at 1,697.441, what are our units?
Gallons.
Gallons. You can just say GAL. That's how you abbreviate gallons. And that is our answer. Choom, 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 choom. All right. Any questions on these notes?
No.
All right. That concludes the notes. Go ahead and write your summaries now, and then you can begin on the homework.